5 to 6. I hope everybody is back now. Welcome to the limb and occultation sensors session, and we start with a presentation of Victoria. So please, Victoria.
Hello, good afternoon or morning. And I would like to make overview of data sets from limb and occultation instruments. And Ozone CCI team from limb occultation instruments includes several teams from FMI, University of Bremen, Karlsruhe Institute of Technology, University of Saskatoon, University of Toronto, and with our help with our validation team from BIRA. As already mentioned by several speakers, that the main objective of the CCI activity is creating homogenized and merged climate data records, and now it is climate data records of ozone profiles. And in my presentation, I will show level 2 dataset, level 3, and merged dataset. And we started our activity with creating harmonized dataset of ozone profiles. What is the dataset? It is level 2 datasets from individual sensors. They are altitude or pressure gridded. They are presented on the same vertical grid. These datasets are user-friendly. All the data are in the same data format for all instruments, and only valid data are included. And this screening is performed by instrument experts. And it is provided all necessary information, geolocation, uncertainty. And for each instrument, there's a set of mandatory parameters and also optional parameters. From the mandatory parameters, there are grids, altitude or pressure or air pressure, and time in order to index the profiles, geolocation, and the ozone data, which is profiles of concentrations, profiles of uncertainties, and profiles of vertical resolution. And also parameters for different representation in mixing ratio or on altitude or in concentrations on different these combinations. And these parameters include profile of altitude as a function of pressure and profiles of temperature. And for altitude gridded HARMOS files, also we included the information about the tropopause height. Optional parameters, they actually depend on, they are instrument dependent, and they mainly may define or affect data quality or data characterization. So these are examples of optional parameters for GOMOS and for MIPAS. So for GOMOS, it is mainly related to star characteristics, and for MIPAS, it is solar zenith angles, and also additional parameters characterizing the quality of the data. And HARMOS data sets are actually they're created for many satellite instruments. Some of them, they are in open access, as for Envisat sensors, MIPAS, SkyMaker, GOMOS, for AZARIS. For GOMOS, it is also one research data product, GOMOS Bright Limb, ACE FTS, and OMS Limb Profiler, processed by University of Saskatchewan. And also exist the same data sets which are available on request from NASA sensors, from SAGE-2, MLS, SABRE, HALO, SAGE-3, on International Space Station, and on Meteor 3M, and POAM-3. And also there's additional OMS Limb Profiler processed by University of Bremen, which are planning, they're also making in open access soon. And there exists a publication about this data set in Earth System Science Data in the year 2013. And actually, HARMOS data, they are used for creating level 3 data sets within CCI. And also this data set have been used in the WMO Ozone assessment in 2014. And these data are used for validation studies and also for process studies, for example, related to ozone hole, ozone mini holes, different perturbation, for example, related to MGO perturbation. And the main level 3 data sets, they are monthly zonal mean data sets. And also there's two merged data sets, CCI OMS, which are monthly zonal mean, and gridded data set, merged gridded data set of ozone profiles. Monthly zonal mean from individual instruments produced in the same way for all ozone CCI instruments and for NASA instruments. And they are in 10-degree latitude means monthly zonal mean from 90 degrees south to 90 degrees north. And depending on native retrieval grids, the ozone profiles are presented either in the form of ozone concentrations on altitude grid or in mixing ratio on pressure grid. And also the mean temperature at altitude pressure profiles are provided. And these data sets are in open access for MIPAS, Kamaki, GOMOS, Azaris, ACS, OMS, CH2, Haloe, MLS, and SABER. For assessment of ozone trends, the data sets from individual instruments are too short. And that's why we created also merged ozone climate data record. And it includes the data from 7 LIMP profile data sets from CH2, Azaris, MIPAS, Skamaki, GOMOS, ASFCMs, and OMP LIMP profiler. It is a merged CCI OMS dataset, and it is a dataset on monthly zonal mean data. And it includes this data and covers the time period from 1984 to 2020, end of 2020. Original dataset was created in 2017, and this original data set was until 2016, but now it is extended until the end of last year. And since it is preferable not performing unit conversion from pressure, altitude to mixing ratio, the instruments included, they are all provide the ozone profiles on altitude grid. So, and also it is altitude gridded, merged data set of ozone profiles. Approach for merging, it is using of deseasonalized anomalies. First, the seasonal cycle is estimated and removed from time series for each data set, and then by this operation, biases are automatically removed. And furthermore, there will be no need to fit seasonal cycles in using in trend analysis. And this approach actually it is widely used as a merging method. And this is illustration of individual data sets and the merged data set. Before merging, we also investigate the stability of individual data sets. And we used only the data which are in very good agreement with each other, and all periods in which we suspect drifts of or suspicious behavior were removed from individual data records. And it results in these examples of merged anomalies, and also we reconstructed profiles of ozone concentrations by restoring the seasonal cycle. So our data set, includes both deseasonalized anomalies, merged deseasonalized anomalies, and also merged ozone profiles. And this is examples of assessment of ozone trends from our paper in 2017, and indicating recovery of ozone in the upper stratosphere. And since its first creation, the CCI OMS data set was used in ozone assessment, and it was used also in the Spark Lotus report, and it's regularly used in the publication State of the Climate, and also for different analysis related to ozone trends. So, and this is a merged data set of monthly zonal mean. And we also updated recently our merged gridded data set of ozone profiles, MEGRIDOP. And it includes the data from 6 limb viewing satellite instruments. And they are also monthly mean, but in 10 degrees by 20 degrees latitude longitude bins. And also they are at altitudes from 10 to 50 kilometers. And this data sets covers the years from 2001 to 2018. And it will be extended regularly in the future. And the satellites instruments included, they have relatively dense coverage, and they are AZARIS, MIPAS, KAMATI, GOMOS, MLS, and OMS limb profiler. And the merging method, it is similar to what we used for CCI OMS for monthly zonal mean data. It is first created gridded data from each individual instruments, computing deseasonalized anomalies. Third, it is merging, which is like for CCI OMS, it is median of merged and deseasonalized anomalies. And then also for other application, we coming from merged deseasonalized anomalies to merged ozone concentrations while restoring the seasonal cycle. And these are examples of gridded monthly mean from several sensors. They are for January 2008 examples with best coverage for MIPAS and MLS from pole to pole, and in January 2018. And this illustration of merging, it is actually it is even simpler than for CCI OMS. It is only computing anomalies, offsetting OMS because of seasonal cycle is evaluated using different time period, and computing median of deseasonalized anomalies. And we performed also evaluation of regional trends in the stratosphere. This is a paper which actually was accepted yesterday for publication in ACP using multiple linear regression. And the trends, it is a simple linear function with the QBO terms, solar cycle, and so on. And we found, similar to previous studies, it's quite pronounced zonal structure in trends and in the northern hemisphere. And this zonal structure, it is actually seen nearly at all altitude levels. So, and overall trends are larger over Atlantic Scandinavia sector than over Siberia. And also in this study, we tried to evaluate also trends in the polar regions. So there's indication on recovery, but because of very large variability, trends in polar regions are not statistically significant. So, and then it is an illustration of last step. It is from decentralized anomalies, restoring the seasonal cycle, and deriving profiles, ozone profiles, concentration on altitude grid. And also this data set allows to creating, as illustration, climatological distribution, ozone distribution, which is not only zonally averaged, but also has some structure, also with longitudinal structure. And we see that climatological ozone distribution, they are not zonally uniform, but they have also structures, which is actually expected and associated with the position of polar vortex during winter time. So, and all data are in open access. They can be accessed either through CCI web page or through Copernicus web service. For Copernicus, it is included monthly zonal mean datasets, merged SH-CCI OMS dataset, and merged gridded dataset Magridop. While for CCI web page, it is also a level 2 HARMOS data are available. And as also visualizing of a summary, it is a number of data sets and their coverage, temporal coverage in time, from single sensors in green and merged data sets. Thank you.
Thank you, Victoria. I don't see any questions in the chat. Nobody wants to ask something. Okay, doesn't seem to be the case. So thank you again, Victoria. So the then continue with the presentation of 10. Sorry, one late question from Irina. Please, Irina.
It takes time to type. Sorry. A question about what you observe from the regional trends, Victoria. Do you have comparisons with the trends in temperatures? Are they looking similar to what you see in ozone recovery trends, or from the regional perspective?
No, we haven't compared with temperature trends. And actually, I even don't know if such analysis is available from. Yes, so they're available for temperature trends. Not compared with the regional trend analysis from temperature.
Okay, so there seems to be no more questions. Okay, thank you again, Victoria. And now we continue with Jan's presentation.
Okay, try to find the unmute button and clicking next. So, hello everyone. This is a companion presentation on the LIMP ozone profile climate data records that Victoria just presented, and this is the part on the quality assessment of these data sets. So I'd like to start off with the table that Victoria showed at the end of her presentation. And this is showing the temporal coverage of all the different LIM occultation profile data records that are being collected or retrieved as part of CCI, converted to the harmonized format and made available as level 3 data sets. And this is done for single sensor records in the green. So these are, I believe, 14 records. And then there's 2 data records that are combined information from different sensors. So that's indicated in the yellow bits. And this was mentioned by Victoria. So this talk is on the validation, and the objectives of the validation is to assess the quality of ozone profile data records, or any product in general, really, by independent means. And here this means using data that were not used to do retrieval. So it's not about intercomparisons of satellites, it's really comparing these satellite products to ground-based data, which can be considered fully independent. So the purpose is to give feedback to the data providers themselves. Since we look at long time series, we can find issues related to the calibration or the stability of the calibration, issues related to the retrieval itself, or issues related to the fact that data sets are gridded while these data sets are poorly sampled. So this is more of a technical feedback that the validation team gives, but also, and more importantly, perhaps for this workshop, is the feedback to users. And we make a detailed characterization of these level 2 and 3 data products and recommend on, actually, we are the first users of these data sets. So we are also making recommendations on how these can be used in addition to what the data providers themselves give. Finally, user requirements are an important part of this process. There will be a discussion on this following this talk. So basically, there were a set of user requirements defined, which were translated to the requirements on the products. We have heard about them in earlier validation talks by Katarina and Arno. And on the right-hand side, you see the table for specifically the LIMP products. So I will come back to this here and there during the presentation. So as a starter, so I mentioned ground-based measurements. For the LIMP profiles, we rely on 3 different ground-based instruments. That's the Ozone sonde. It's a global network giving access to troposphere and up to mid-stratosphere. There's the stratospheric ozone LiDAR network, and there's the ozone microwave radiometer network. So all of these perform routine operations within network context, like NDAC, supported by GAW, and there's the important Shadows network. So all of these publicly available data records were collected at a number of sites across the globe. So this is just a map of where you can find the stations, and we only perform our comparisons around these sites. So you see that while the SOM network has a fairly good sampling, it is much less the case for the LiDARs. That's the red crosses. I believe you can see the mouse. So this is more inclined, and it populates the northern hemisphere better than the southern hemisphere. And then the microwave radiometer network is even smaller. Yet the value of using these different data records is that these are different instrument techniques. So if we see issues reappearing in comparison satellite to ground-based for the 3 different networks, we really can be sure that there is an issue with the satellite record. So the value of having multiple independent reference instruments is very important, especially if you like to detect and rule out any subtle effects in the satellite data records. I cannot stress this enough. So first part of the talk is on the level 2. So level 2 are individual profiles. I won't go into the details that I mentioned in text here, but basically the analysis is looking at co-located profiles of satellite and each of these ground-based sites for the different sites, for the different ground-based techniques. And we make sure to reduce as much as possible in the measurements. For instance, the differences in units or vertical resolution or the grids, to try to have an as comparable comparison as possible. And you can see over on the bottom right, sorry, the map of the number of collocations we obtained in the analysis of OSIRIS with respect to these 3 different ground-based networks. So it shows global coverage, and this allows us to detect subtle features. So then once we have done this pre-processing, we look at the difference time series and we infer some quality indicators. that I will illustrate in the next few slides. All of this is described in detail in 2 publications by myself in 2016 and by Arno. He already referred to this a year ago. But also, and perhaps more comprehensively, in the reports that are produced within the CCI project and also the C3S project. So these are not purely management reports. These are really reports that are publicly available, and their purpose is to be read by users. So this is you. So these reports contain a lot more technical details and more plots than you will find in our papers. So first, what are the quality indicators for level 2 profiles? So here I show just one example, one time series of Skiamaki minus LiDAR measurements at at one altitude level. So we look at the bias, so that's just the median difference in these, the median value of these relative differences, On the bottom left, you can see then, if you do this for all altitudes and latitude bins, you get a nice view on the spatial structure. We also look at the dispersion in the differences. So that's an estimator of the spread or the variability in the comparisons. And we look at the spatial structure, etc. And then finally, and especially for climate purposes, we also look at the long-term drift or the stability of the instruments. So here at the bottom right, you can see the drift results for Aura MLS with respect to the three different ground-based instruments, so microwaves, LiDARs, SONs. So I cannot really go into much detail because there are way too many data sets. So I will give a sneak preview of what is prepared and what you can find in these reports. And if you have any, if you lack any information, do not hesitate to contact us for additional information. So the bias, this is, we've heard about this for quite a lot already in this workshop. It's a very simple indicator of the agreement between satellite and ground-based. Here is an example of the comparisons to the stratospheric ozone LiDARs at mid-northern hemisphere latitudes, in the middle northern hemisphere, for all different satellite sounders that are part of the LIMP portfolio. And you can repeat this exercise for, at the bottom row, all the SOMs, all the LiDARs, and the second row, and the microwaves at the very top. So you see the different vertical ranges. And basically, the conclusion from this is that there's lots of data sets, but if you look in the middle stratosphere, and I define this as a region between 20 to 30 kilometers, the agreement is the biases are typically less than 5%, so that's plus minus 5%. In the upper stratosphere, it's more of the order of plus minus 8%. If you go higher up in the lower mesosphere, we basically only have the microwaves to do the comparison, and you do see some larger differences between the data sets. It's more tricky to do these comparisons, so I would indicate this as more of an indication than of a real very precise or accurate estimates of bias, but it gives a good indication of possible issues. Also, the lower stratosphere is a difficult region because of the higher variability in the comparisons, because of the higher natural variability in the atmosphere. So we are always comparing profiles that are collocated, but they are rarely collocating exactly in time and space. So you have this natural variability that enters the game. But still in the lower stratosphere, agreement is within 5 to 15%, which is not too bad. Second indicator is dispersion, so the spread in the comparisons. Again, for all the different ground-based techniques, SONs, LiDARs, microwaves, all the different latitude bands from Arctic to Antarctic on the right-hand side. And what we can see here is if you overplot the user requirements, which are 8% in the stratosphere or above 20 kilometers and 16% below 20 kilometers, we can actually see that in the middle and upper stratosphere, these most data records actually comply with the requirement on uncertainty, and that's considered. It is considered that the user requirement, and that's some point for discussion perhaps during the validation, the requirements session, is here the requirement is on the random part of the uncertainty, assuming that the biases are known and corrected for. So if you do the job and you correct for the biases, then the requirement is 8% on these dispersions. I'd like to mention that especially this indicator dispersion receives another unimportant contribution from the natural variability in the comparison. So you actually have upper limits to the actual precision of the satellite data. So the situation is better than what is quantified here. And still you see in the middle and upper stratosphere, the agreements are met for most sensors. In the lower stratosphere, particularly, variability increases very rapidly with decreasing altitude because of the variability in the atmosphere. In part because of this, also because of the loss of signal to noise, that loss of signal by the measurements, by the instruments. So the overall very good situation. And finally, for climate purposes, drift, the stability of these data sets is very important. And here I show again the drift with respect to the network. So this is actually an analysis with respect to the entire network, not split up by latitude bands. And here we see for comparisons to sound, LiDAR, and microwave that also the user requirements of 3% per decade, that's the green shaded area, I hope you can see it, is met. There are a few exceptions. I won't go into detail here. I invite you to read the reports. And if you have questions, feel free to contact me. However, these type of issues with some instruments in part of the data sets or part of the altitude range are taken on board or are very useful for interpreting, for instance, trend studies, and I will come to that back later. They also go back to the data teams, and Victoria made use of part of this information to find out how to best merge or screen data sets prior to merging. So a second part, which is shorter, is on the level 3 records. Level 3 is actually tricky. I write here evaluation methodology rather than validation methodology, mainly because level 3 is all about gridded data sets. And these satellite records, the gridding is very coarse. So these are monthly means typically, and these are zonal means typically. There's also the lat long gridded product, which is 10 degrees by 20 degrees. Still, it's very hard to claim that the ground-based measurements are representative of a monthly mean state, because there's typically a couple of measurements a week or a couple of measurements a month. So you have a handful of measurements by the ground-based instruments, except perhaps for the microwaves, they really measure continuously. But on the other side, you also have the sampling of the zonal belt, which is not representative at all. You have a few sites for one belt. So sampling and representativeness is a big issue. Also, if you want to compare to a zonal mean, you have the challenge of the differences between the ground-based sites. So in the previous analysis, we were always able to look at actual collocations of satellite over one site and then aggregating those differences. Over here, you really have to aggregate the sum data before doing the comparison, and then you have the issues due to the differences between the sites. I forgot to mention that for this study, we focus on the SOM network because this is the most densely populated network. Work is ongoing to also look at LiDAR and microwave network to see how far we can get to evaluate these gridded satellite data sets. So this remains a challenge. We also need to adapt the methodology because these satellite products are presented as, for instance, as deseasonalized anomalies. So we have to create deseasonalized anomalies, create these zonal means, and etc. So all of this is described again in these project reports. And once we've done this preparation step, we again go and look at bias. So here, for instance, this is the latitude pressure cross-section of the bias of HALO, which is an instrument flown by NASA at the end of the 90s, early 2000s. And this is just the bias of this data record. This is the dispersion in the comparisons. So here for the comparisons, we do not look at actual concentrations, but we look at the anomalies of the HALO record. And this is already removing a lot of the variability in the atmosphere and in the comparison. So that's a more accurate way of estimating dispersion by looking at these anomalies. And then finally, there's the drift of HALO with respect to SONS. So all of this in level 3 that I present here is just comparing to SONS. So next slide. Is it? Yes. Okay, good. So this is the level 3 comparison of the merged CCI OMS record that is used in various assessments. So on the left-hand side, you can see the bias. Because SAGE CCI OMS is presented uniquely as anomalies, by definition, comparing a difference of two anomalies, one anomaly of the satellite anomalies and the ground-based anomalies, by definition or by construction, you end up with very small biases. So it's not really valuable here. So more interesting is the dispersion, so the measure of the spread in the comparisons, which is within the requirements of 8%. That's the ISO line here in white is the 8% line. So you see above 20 kilometers, it meets the requirements. And below that, it even meets the requirements of 16% for a large part of the stratosphere. Also, the stability of this merged record is very good. And this is in the altitude range 10 to 30 kilometers. So it's not in the range above in the upper stratosphere. It may be that the results are different there, but that needs to be verified with different ground-based instruments. And then finally, there's the gridded data set. So this means lat-long gridded data set. These are results of a preliminary version, which did not yet include the MLS measurements. On the left-hand side, you see the bias of the CCI product with respect to the SONS in different grid cells. The colored ones are the grid cells that have more than one site. So that's not too much. And then the gray lines are cells with just one site. So you can appreciate the spread across in bias results across the sites. Also, the dispersion is fully compliant. It's actually the variability or the spread in the comparisons is much lower than the 8% requested by users. Even in the lower stratosphere, many of the grid cells, some grid cells, sorry, offer spreads lower than 16%, but at other grid cells, you see at the very bottom, there's a lot of differences between the different grid cells that are evaluated. And especially drift, that's why for drifts results that I presented at level 2, I mentioned this is an estimator considering the entire network, and the exact reason is why we do this is shown here. When you derive drifts at individual sites or here at individual cells, you see a huge scatter between these cells. So you have to average out to find a more accurate estimate of the drift. So this is, I would say, not really constraining drift a lot. It's indicative of possible issues, but it's a difficult estimator for a gridded data set. And
Then time for.
Yeah, I'm almost done. So just one slide on the actual usefulness of these results. So These analyses are very useful, for instance, to find out why trends differ for different data sets. So I show here the data sets, the LIM data sets that were used by the Lotus activity and also taken up on board by the WMO assessment last time. So while the generic spatial structure is very similar, quantitatively there are differences, and you can really relate those differences to what you see in the level 2 comparisons. So more general, if you want to interpret results in a proper way, it's really valuable to have these validation results. So my final slide, I think my main message is that most LIM climate data records are actually in a good state. They comply with user requirements. Yet there are some issues for some CDRs that need to be taken care of or taken into account. So I invite all users to look at our reports. So there's the Ozone CCI product validation and intercomparison report and the C3S product quality assessment report, which will receive updates very shortly for updated data records. And I'd like to stress, we will also make sure that our estimates are not, or find out about the sensitivity of our quality estimates to issues related to the drop-off in the ozone zone network. And that's it. Thank you.
Yeah, thank you, Dan. So maybe one short question. So if you have a question, you don't need to type it whole, just type something. Yeah, Irina again.
I'm sorry. The reason I'm asking about what document is used to define the user requirements is because recently I participated in the GCOS assessment of user requirements, and there is now WMO is writing also a document on the user requirements for the ozone data. So just curious what the CCI is using as the user requirement.
This will be discussed, I believe, in the next talk by Jean-Christopher. Short, it's a collection or an interpretation of the collection of requirements that are available in the community and prepared by our climate research group. So
okay.
You can see Michiel van Wele, for instance, responding to this.
Yeah, thank you, Michiel. Okay, we have to move on. Thank you then again, and we continue with the presentation of Jean-Christopher.
Yeah, hello, can you see my screen?
Yes, we can see it.
Perfect. So no, this presentation will not be about user requirements, but user requirements on data validation and quality assessment. That is one of the main processes in generating climate data records. We will start with some words about requirements and indeed address the origin of the user requirements used by the different teams. Then make a status of advances on data methods and reporting we made in the framework of the CCI project. Address more specifically some application specific validation requirements, and then list lessons learned and challenges, and also open the floor for new requirements for upcoming missions. So about the Ozone CCI user requirements, actually, there is a document that you can find on the website, of course, the URD user requirement document, updated only a few months ago. And the main sources for user requirements are the GCOS implementation plan, some significant input from climate research and modeling people, from the climate research group and the climate modeling user group of the CCI project and program in general. Also some requirements from IGACO 2004, still valid, and user requirements that you can find in the rolling requirement review of WMO, with some requirements specific for climate, atmospheric chemistry, Spark, that includes, I guess, the Lotus and Octave UTLS and long-term trend assessments, and NWP. just here an illustration of what you can find in the GCOS to implementation plan 16. Then from user requirements, we have to translate into validation requirements. And we start, of course, with validation of the measurement, ozone concentration or column over the full range and the domain of use. We need also to validate the uncertainty estimate associated with the data product and other characteristic requested by the users like horizontal and vertical resolution, the altitude registration, that is something not mentioned in, for instance, the GCOS requirements, but expressed by the climate research community, the error bar not only on ozone, but also on the altitude registration. And then from the ATB, the measurement equation, in other sources, we can also identify a list of retrieval and inference quantities over which validation should be performed and quality indicator assessed. The diagnostics are something quite classical to look at the averaging kernel, derive the degree of freedom of the signal. The centroid of the averaging kernels can give information on the altitude registration. There are then a lot of parameters, solar zenith angle, viewing zenith angle, the properties of clouds and aerosols, the profile of temperature and absorber, surface properties, and in the case of GOMOS, or stellar occultation missions, star brightness, obliquity of the occultations, and other parameters. And just to give you an example from another project, you can actually draw a table with the inference quantity, the spectral domain where it is useful, the range of inference quantity that for which we should have validation measurements. That's something quite classical, I would say. So in the Ozone CCI project, we made some advance regarding validation data, also called sometimes fiducial reference measurements if they meet some clear criteria. And we made some progress about the fitness for purpose of validation data. All data provided by networks, for instance, are not suitable for validation. The quality assessment, the QA monitoring of the ground-based on validation data. Feedback to data originators was also very helpful, mutual feedback, I mean, from the data originators and to them. The interaction with monitoring networks was instrumental in improving the fitness for purpose, timeliness, uncertainty, characterization of the data. We made also significant progress on the validation methods, tools, and reporting. Several new or upgraded methods for harmonization of the data sets of the validation chain, verification of compliance with user requirements, the validation of ex-ante uncertainty estimates, with some advance with new techniques, consistency test, some for total ozone, the closure of the comparison error budget, taking into account not only the uncertainties of the satellite and FRM datasets, but also collocation mismatch, smoothing differences. The design of a round-robin methods for the investigation of mission interoperability. Significant progress, but still not at the end for the validation of level 3 and level 4 data products and the developments of suitable validation for the C3S climate data records, and so on. A few illustrations of application-specific validation requirements we have to address now. In the tropospheric ozone assessment report number 1, the first phase, just finished a couple of years ago, some papers, and especially one by Audrey Godal and colleagues, pointed to several issues with the satellite data. They all report trends and variation in tropospheric ozone, but with different values. There are differences in vertical sensitivity and sampling, which matter, difference in tropopause column definition, tropopause burden. The biases are changing over time, and they noticed also inconsistency with TOST, so ozone zone-based trajectories. That's why in the new phase of TOR, a satellite ozone working group has been set up to address all of those issues, and it has the support of a dedicated SEOS activity on satellite tropospheric ozone. Another application-specific set of requirements is when you deal with satellite constellations and the problem of interoperability. So several papers show pretty well that major geophysical features and trends are well captured by satellites, but that there are biases between satellites changing with time, that difference in sensitivity, resolution, and sampling really matter. Sensitivity difference are not that easy to assess and handle. Data harmonization can improve mutual consistency, and it's essential to establish common validation practices among the constellations. And sometimes not just data comparisons, but also investigation of geophysical features to see how they are consistent, or the way the satellite capture those geophysical features are consistent. Another kind of application-specific list of requirements is when you deal with merging data records or even data assimilation, like done in CAMS. Several papers again show that merge climate data records and reanalysis, the quality depend on the ingest satellite data. It's not a secret, of course, but such papers point to very specific issues. Temporal inconsistencies affect trends and interannual variability assessments, and sometimes also intra-annual variability assessments. Those are interesting things to look at. So during those years of Ozone CCI activities, we learned several lessons and identified also remaining challenges about satellite data uncertainties and QA/QC. For a successful validation, we need state-of-the-art ex-ante uncertainties, and the CCI project made a significant progress in harmonizing and deriving systematic procedures to have the best ex-ante uncertainties as possible. Efficient quality control of level 1B and level 2 data production is necessary before validation can start. About validation data, the monitoring networks of the global ozone monitoring system, you know them, of course, NDAC, the Brewer and Dobson networks, the Ozone Zone, Shadows, and so on, are valuable source of validation data, but it's not their primary objective, and sometimes they need further calvalalization. This is a word introduced by Patrice Henry from CNES, and I like it. Fitness for purpose of the validation data, representativeness, inference quantities can be further improved, something to look at very carefully. Reliable uncertainties of validation data. About operational aspects, timeliness, sustainability, QA/QC of the different FRM data streams is something important. We managed to make some progress, but there are still challenges to be addressed. Mutual feedback and cooperation with the ground-based networks is really fruitful. It's very important to give feedback and to receive feedback from the networks. And finally, satellite-to-satellite validation can be further tailored in this project or in other projects. Usually it's limited to data comparisons, zonal means, and things like that, which are okay as long as we are in the stratosphere, but other things can be done. And for instance, triple collocations can enable the validation of the precision, or let's say the random uncertainty, which is something more difficult to obtain with data comparisons, peer-to-peer, I mean. We made also progress with methods, but we see also that harmonized state-of-the-art fit-for-purpose validation methods, although quite mature for several ozone data products, are still in refinement. Sometimes they have to address stringent user requirements or new user requirements. High-resolution data validation is also a new challenge, and in the validation chain, we should sooner or later include geolocation validation, which is not something we are used to do in the atmospheric domain. Propagation of uncertainties along the full chain of harmonization and validation, all those data manipulations introduce uncertainties, and we are not really able at the time being to propagate all of them and come to a complete comparison error budget. Although we have closed a comparison error budget for total ozone to some extent, including collocation mismatch errors. Higher level data products are hard to validate. We made progress with level 3 and 4 validation, but we are not at the end of the story. The verification of compliance with mission and user requirements is not straightforward. For the reporting, we made with this project and others significant progress with full traceability of the validation data and validation process. And no challenges remain with the validation of regarding interoperability requirements. And also the change in paradigm of geo observations with respect to LEO. Maybe the diurnal cycle in the upper part of the stratosphere, but also different sensitivities with respect to the ground, with clouds, and many other aspects that I don't have the time to detail here. So for upcoming missions, you know that for Ozone, Isa and colleagues are working on the Earthwatch element Altus, a limb scattering solar occultation, stellar occultation mission that will be launched in a few years. The PDGS is under development, and this includes development of CalVal requirement documents for this mission. And CalVal requirement documents are also in development for the Copernicus Sentinel-4 and 5 missions, addressing the LEO and GEO questions, or at least raising those questions, and the high resolution issue, and many others. And there are also, you can find them on the CEOS website, several white papers describing validation and interoperability requirements for the air quality and greenhouse gas constellations. So this is the end of this talk. And we will start after maybe a few questions, the discussion of this day. There are several topics that will be addressed, but one of them is actually the establishment of CalVal requirements for Altus and the Copernicus Sentinels 4 and 5. And we will have an opportunity today, but also tomorrow, to discuss and refine validation requirements for Ozone CCI climate data records, but also for upcoming missions. And yeah, I thank you for your attention. I don't know if you have any questions.
Thank you, Jean-Christopher. Any questions? Don't see any. So, no, this was not a comment to Jean-Christopher's talk, right? That was for previous one. Looks like.
Yeah, the rolling review of requirements. Yeah.
So it looks like there are no questions to the talk, so we can move to the discussion.
Yeah. And so for the discussion, Victoria and I have established 3 main topics for discussion about the climate data records, the validation requirements, and the data stewardship. And I think that Victoria will start with the first topic.
Yes, so just a few questions related to climate data records. And for example, which data sets are the most useful? What is missing? And what are other recommendations or different suggestions for improvement, extension, etc.? Please.
May I
Sorry,
make a
can you
comment?
put?
Sorry, go ahead, Irina.
No, I was just going to ask to clarify this question. Are we discussing the CCI data sets now?
Yes.
Okay.
Maybe I can add something, mention something. Data sets are most useful when I have to talk from my gut feeling is that the nadir profile records produced within CCI may be of great value for the long-term trend studies. At the moment, trend assessments in the stratosphere from nadir viewing instruments have only relied on the SBUV OMS time series. So I think having the GOM type nadir profile long-term record will be very valuable and interesting to finally see how these SBUV instruments how they perform with respect to another sensor.
I can say something, can I?
Yes.
Sorry,
Yes.
I don't want to overwhelm this meeting with my multiple questions. If somebody else has something to say, go ahead. Or is it okay?
Yes, please.
Oh, okay, so I just want to mention that I'm really excited about these gridded data sets and the fact that you've worked on homogenizing them and creating already some trend analysis. And that comes also from perspective of the ground-based observations when we typically try to compare the few ground-based stations with the zonal averages created by satellite records. And we struggle with the sampling issues, etc. So I think this is really a great opportunity now to start looking at intercomparisons between the gridded data and ground-based stations. And so looking forward to that.
Yes, I fully agree. Good.
Can I chime in? It's Mark from Bremen. I think
Yes.
we have seen, and also during the CCI period, we had the largest numbers of co-flying limb instruments available, which was very valuable to really pin down on the quality of the data sets. But in the future, there will be fewer limb missions. So at the moment, we have only Altius. I think on the NASA side, there will be another OMPS limb sounder. But other than that, it doesn't look very good for high vertical resolution measurements from satellites. And then, of course, then the point from Dan will become more important since we have a number of nadir measurements in the next decade. So there will be enough sensors. So the profile data. So we will have to rely more on nadir profile data for trend assessment. Of course, the vertical resolution is lower, and also there are some issues, particularly in the UTLS region, which is also a very climate-sensitive region. So I think that's something we have to be concerned with in coming years.
Yes.
What about the OMPS limb profiler data? Is that going to be going forward? I keep forgetting, that there are sometimes some satellites that carry that and some satellites they don't. Anybody here who can say something about that?
So the current situation is there's no profiler at GPSS1, but there is a limb profiler planned for GPSS 2, 3, and 4. But this might change.
Birgit Hassler here. I think the most useful data sets are those that you can easily access and easily use. So the merged data sets are obviously or for me, the obvious choice for any analysis. You have to make it as easy as possible for the user to access the data and to do something with it. And so it is important, I think, that people who know the data really well do the merging and do the gridding to make sure that the data is as good as possible for everybody, so that everybody can easily use it. So yeah, there are some really great data sets out now from ESA CCI. It's just fantastic to see. So I think those data sets are definitely the most useful for, in my opinion, for the wide user community.
Thank you. Yes, and this is, point is really important. It's easy access and straightforward, and also actually good web pages.
And question to Birgit, but also to everybody. Are you happy with the coordinates, so in pressure and altitude, or are there emerging applications where you need something different, like, I don't know, equivalent latitude and PV levels, for instance, in Octave UTLS, maybe?
I think it would definitely be beneficial. I think as a first instance, I think the pressure and altitude is fine, because that is what is mostly used for the regular trend analysis that you're looking at, for example. But I think if you want to go into more detail to disentangle, like, where is the dynamics playing a big role, or like, is it with respect to the tropopause, like what can you see in the UTLS region? I think those alternative coordinate systems are getting important to actually look at that in more detail. So yeah, if you are planning on doing that, that's great. If you're gridding data according to equivalent latitude PV levels, then that's great.
And from a user perspective, is there a kind of consensus on what should be done? For instance, potential temperature equivalent latitude, and in that kind of bin with that kind of resolution, or is that really dependent on the application and the study?
I don't know for sure, but I think it would be dependent on the application, but maybe Wolfgang has a different opinion on that. Yeah, so I would think it is dependent on the application, what you want to do.
I think it would be useful if the additional parameters will be provided, maybe in the form of collaboration with, for example, with Octave UTLS project. Not just in the data set, but provided together with data set.
So you mean it would just be an additional parameter, like with a data set that is on pressure and altitude or something?
Yes, like this.
Then again, I come back to the point that it's probably too hard for people to use if it's not served as something.
Okay.
You know,
yes,
it's definitely nice to have that, yes. And I think like very motivated users would use it. But if you have it as a grid data set in a different coordinate system, I think that would just be the way to go. But
yes, it would be easier. Yes, good.
But then, this is Wolfgang speaking. I kind of start seeing two problems there. The one problem is that you kind of mix between reanalysis and the satellite data when you go to the other coordinates, because usually they don't come out of the satellites. And the other thing is, if you want to look at things in detail in the UTLS, you probably cannot go with monthly means or things like that, because there's just too much happening.
Mm-hmm.
Yeah, this is Antje Innes here from ECMWF, and I'm coming from the reanalysis perspective. So we are definitely interested in all the individual data sets as level 2, but it is very important that, yeah, they are long-term data sets, that there's consistency between the different instruments. If you go from going to A to B to C, and so on. So, yeah, it is very important that those consistent individual data sets will be available. And one thing which I'll also mention in my talk tomorrow, for us is it's very important that the production of these data sets continues if possible. Because normally you go and produce a data set, say, from 2005 to 2020, and we use that data set, but with our reanalysis, we keep running on into near real time. And at some point we have to switch to using near real time data because the reprocessed data aren't available anymore. And then we see problems in our data set and inconsistencies. So if we can have data products that perhaps continue to be produced a few weeks or a month or so behind near real time, that would be really, really useful. Yeah, that was all of my comment.
Good point. Herman, please. I see.
Yeah, I have actually a question about picking up Mark Weber his comments on the LIMP. I can understand that when you're doing LIMP observations, you're addressing more. You can also more addressing transport studies. But if you would look purely on trends analysis in the troposphere or in the stratosphere, and also for the impact on climate change, and how far the LIMP is then still essential, or is it something which I'm not a satellite expert, but I would call it then a luxury to have this. It's wonderful to have it, but could you rely on LIMP measurements and get same kind of conclusions which you're doing nowadays with trend assessments?
Can I say
also
something?
ask in a different way, if you would do an analysis and you would take out all the LIMP observations, would you come to the similar conclusions, or would that be different?
Can I say something to it? It's Mark.
Yes, sure.
Yeah, I think we had this discussion as we had, I think together with Michel van Wiele, we had this, we tried to set up requirements for operational use of LIMP measurements. And I think we came up that probably the upper stratosphere is a good region for nadir products because you don't have asymmetric kernels. It's a good altitude determination, but you have slightly lower vertical resolution. But the problem with the upper stratosphere, particularly with regard to UV measurements, is that you need the lower UV range of the satellite measurements, and these are strongly affected by optical degradation due to harmful UV radiation. So the question is, how good is the quality if you go really up, like, so I say, above 30, 40 kilometers? In the UTLS, what we noticed that the nadir profiling has much lower sensitivity, particularly in the UTLS. So I would say probably the profile from the UV have almost no sensitivity in the UTLS. It's a bit better with thermal infrared sensors, but there's certainly some issues in the UTLS. And so I think in that regard, if you need high vertical resolution, because you want to separate troposphere from stratosphere, I think you have to use LIMP measurements if you want to use satellite measurements.
Is there, just one question, Mark, is there something then going on to convince people that there should be a LIMP mission again?
Yeah, my opinion on that is that at the moment, most of the also space agencies, they focus much more on air quality. Mm-hmm. So basically they're saying, okay, the stratosphere, we know everything. It's nothing really new. So the focus has been lately very much on the troposphere. And that, of course, favors the nadir measurement, because only with nadir measurements you can go and measure to the ground. So we try to, there have been a lot of attempts also proposing new missions, but it has been very difficult to get funding or large enough interest from, let's say, also from the public that we need, or from some other areas that we certainly need limb measurements. So maybe somebody else can also add to that.
Yeah, this is Christian from ESA. Maybe I say something to that. So the new missions, Copernicus, I mean also the current one, no, Sentinel-5P, and the new missions, Copernicus, Sentinel-4, Sentinel-5, the Copernicus monitoring mission for CO2. I mean, these are driven by the European Commission, basically. No, I mean, ESA builds these platforms, and of course defines also together with the users what the recommendations are. But after all, they come because the European Commission puts money on the table. So it's not like the space agencies, or let's say not from the European side, that the space agency says, well, we are more interested in air quality and nadir measurements. It's driven by also different mechanisms, if you want.
And another thing is we cannot just look at ozone. I think we have to think of other trace gases as well. And really, when MLS dies, we're gonna be behind to a lot of things.
Yeah, and I mean, good that you say that, because I mean the thing is also a little bit, let's say that the science behind is also a little bit broader. I mean, now we can measure also a BRO and OCLO, so chemical species that contributing to the ozone depletion and so on. So these things are possible with native sensors where you have issues with limb. But of course, I mean, the limb capability needs to be there. That's for sure.
Good. If there are no further comments, I propose that we move to the second topic.
Yes.
About validation requirements. And so there are questions for the current climate data records. Are there new or insisting requirements for the validation data, for the validation methods, and for the reporting? Same question for Sentinel-4, and for Altius, and for the satellite constellations. And maybe to start the discussion, I would ask a question to Antje Ines from CAMS. In the set of quality indicators that validators provide, is there something absolutely necessary for you which could determine whether or not you will accept to ingest a data record?
That is difficult to say. To be honest, I mean, it'll depend a lot also if this data record is the only one of its kind, then I guess the criterion will be perhaps not as tight as it is if there are several instruments providing the same data record. So I think bias and stability is perhaps, yeah, the most important thing we look at usually. And then we test data in our system and do our own validation on our analyses to see how it performs. And we often find that we get good results if we combine a limb sounder with the total column ozone, for example, from nadir instruments.
Okay, thank you. Any other thoughts about validation needs for data improvement?
I would maybe have an addition to Antje's previous remark, stating that having available nearly operational data, or with let's say monthly delays, would be a nice thing to have. But for example, the YASI data are provided on the IRIS portal in such way. Actually, it's a 1-day delay, I guess. But there we have, as validators, the problem that we can either validate reprocess time series that are internally consistent, let's say, because or we can validate what is online, but then there are version changes during the upload. So and then we the discussion is: would you prefer full validation of reprocessed data sets, or can you live with just validating, let's say, per year or per month what is online, what is effectively available online?
So a question for me. I guess ideally we would like the reprocessed data sets to continue, that we don't get a version change if we use the data in the reanalysis. I mean, obviously at some point it has to happen.
Yeah.
But we always see the impact of that on our reanalysis products. So if the older reprocessed version can at least be continued for a while, that would be very, very useful. Otherwise, I guess once we've had to change to the newer version, then obviously the validation of that version is enough for us.
Yeah, so ideally they are available both for a period where you can, or we can validate and test.
Yeah, or if you have an overlap period, at least then, yeah, you can document the differences in the versions.
Yeah.
Angie, what would be like a typical time frame that you would like to have an overlap so that you could adapt to the new version?
Well, I guess if it's a different version, unless it comes with a bias correction scheme for that version, we will always see a change. For example, for our current CUMS reanalysis, we started, I think, in 2017 to run it, and we went back to 2003 and then ran it forwards in time. So at some point we caught up with near real time, and now we run it a few weeks behind. So we had to change to near real time data. I think some point around 2018, 2019. So if the reprocessed data could continue for, a few years, that would be very, very useful for the long-term consistency of reanalysis data sets.
Okay.
For Antje again, what are your real needs for a kind of near real-time validation? So far in the Ozone TPI project, we validate the data records once per year when there is a delivery of a package, but this is certainly not near real-time. What are your exact needs, and in volume, but also in timeliness? Is that a couple of weeks, 3 hours, 3 months?
Well, it depends if you continue the data sets close to near real time. I guess if that was the case and we were requiring those data to use them in our reanalysis, I would say perhaps every month or with a month's delay at the most. If the data are further behind and we can't use them in the reanalysis anyway, then it doesn't matter, and there's no time pressure from our side, because we by then will have switched to some near real-time product.
Okay, thank you.
This is done. I would like to raise one point as a member of the validation team and being confronted with user requirements. One thing that in my view is sometimes lacking is that it's not really defined for what product the requirements hold. And I'd like to perhaps explain? For instance, it's not really defined whether the requirements hold for individual measurements or whether they hold for monthly means or for zonal means or for whatever aggregation level. And this is really important because if you look at a monthly mean product, by nature, you average out a lot of the variability or measurement random uncertainties. So that's something that should be very clear for the validation team at least. So I don't know if there is anyone with a comment on this, whether this is taken on board for these the setup of these requirements.
Of course, I could react from the being the author of the user requirements document in the Ozone CCI. So my name is Michiel van Welen. And so I have been also involved in the update of the GCOS requirements. And this is, of course, every time something that comes up, how do you define the requirements? And there's a certain GCOS style. And then there are different attempts over time, like in the WMO rolling requirements, to overcome this. And one of it is to look at applications. And another is to make the products more and more granular, that you do not talk about ozone, but about ozone profiles or a certain in a certain region. But of course, the more detailed you make them, the more difficult it is to set generic requirements. So in the end, there's not really a solution to it, except that you set up user requirements per application that you have in mind. And I think that's the only way to proceed.
There's a question from Herman.
Yeah, I got a question actually. It's a bit in the same style as Dan posed the question. And for me, the keyword is representativeness, especially when you're doing these kind of zonal means, and especially when you then take an ozone sonde, and that ozone sonde should then take for 1 month the representatives of the zonal mean. And you see when you do this into comparisons that it's getting dramatically, and this has nothing to do with any of the satellite observation or of the sonde observation. It's purely the atmosphere is so variable, and I did in the past, we did an exercise with water vapor of satellites and ground-based instruments, and each of these instruments have got their specific time scale on which they're measuring, and from the variability you're getting from them, you can get a kind of atmospheric variability on different time scales. And when you're doing then an intercomparison in space and time, then you can get a much better metric based on this kind of correlation lengths of correlation times. Then when you do just take, okay, I take 6 hours and then 10 degrees, or I take a zonal mean, because this is actually still based on a bit on an artificial level. Is there any thoughts done in the past within this satellite community how to deal with these kind of questions?
I can answer.
I fully agree with you, because of it is definitely worth to compare parameters which are comparable with different representativeness. It's okay. We can compare, but we cannot draw any conclusion from this comparison. And then it is actually standard way. It is using collocated data. If they are averaged, then use averaged overpasses. And in order to exclude what is actually happens in the atmosphere.
For the validation of level 3, yeah. For the validation of level 3 total ozone data produced by DLR, actually Tyle Verhulst did a couple of years ago a study of the sampling, the representativeness errors in preparation of the comparison of gridded total ozone data and total ozone data by Brewers and Dobsons. And this is actually published in one of the previous papers by Melanie, where you have an assessment of this sampling error, but this is only for total ozone, not for the profiles.
Yeah, no, for me, I understand this is very difficult, and I don't want to blame anybody. It's more for myself if I see all these graphs and comparisons, and there is no quantitative objective criteria where you say, okay, oh, here we have a problem or we don't have a problem with one of the instruments. Because you always can say, yeah, that's probably atmospheric variability, and then it's so the hard conclusions are never drawn.
Yeah. This is actually one of the challenge in the list you have seen in my presentation, the representativeness. We have to work on that, yeah.
Yeah, no, that's...
Actually, time is flying, and we have only 5 minutes for the next topic. I heard some noise. Maybe a last comment on validation requirements, and we move to the last part.
Well, I just wanted to say that some of these things are very hard to get around. I mean, if you don't measure at the exact same time with the exact similar altitude resolution in the lower stratosphere in the same place, there's nothing you can do about it. You're going to have that atmospheric variability in there.
Yes, I agree with you, Wolfgang. There's only, you can get some a bit of quantitative metric about what kind of variability you can expect, for example, for ozone on a time scale of 100 kilometers difference, then you could expect at a certain altitude from the known variability which you have, you can get already a bit of a quantitative measure of, is this then sinful that I still compare these two with each other, or I actually can already say all the differences I measure is actually purely atmospheric variability. There is then also implicit, of course, the instrumental differences, but they are totally solved in the atmospheric variability. So you not can really distinguish between each other, and I think you can get a bit of quantitative criteria where you can exclude already the bad and the good stuff from each other, and not only still have the discussion on the atmospheric variability then.
Okay. There's also comments from Angela.
I thank you, Victoria. Just very quickly, because I know we have to move on, but I think also there is a need to really push and coordinate whoever is responsible for the ozone sonde network. Because from what I understood from the verification talk, I think it was Dan who gave it. Sorry if I'm wrong, but there is not enough frequency of ozone sonde data to really validate the profiles, and also to be able to give a very good gridded product. So I really think that we need to work, perhaps the ozone community, satellite community, needs to work with the people maintaining the ground-based measurements, and maybe like involve also the WMO, because these observations, my understanding is that they're not mandated. I think people, they just do it, but they're not officially mandated. They're not like temperature or humidity, where each member state of WMO has a mandate to provide those observations. So I really think it's quite important, at least to maybe increase the frequency instead of twice a month, maybe once a week. I think already that would help, but I think there needs to be an engagement, a dialogue with the people responsible, or the entities responsible for the ground-based network.
And there needs to be the money.
Yes, of
I
course.
think, Angela, you're running in open doors, but as a Wolfgang said, I'm strongly involved in the Ozone Zone network and the quality assurance, and we're running a network at the moment maybe of 60 active stations, and to keep them alive is already a hell of a job. So if you start to ask for more stations or to increase the frequency, this is, if ISO-WMF would give us the money, or CAMS would give us the money, we would certainly spend the money in a good way. It's financially.
I understand. Yeah, thank you.
But thanks for the remark. I think this is, when you talk about temperature and relative humidity, this is another part of WMO. This is the weather forecasting, and there are complete other rules about financial aspects. Because
yes, but
weather forecasting is a commercial product,
yeah,
and GAW is a research product, and then
yes.
then
You're absolutely right, but we are trying to bring it more and more together, because now WMO really cares about also air quality forecasting, you know? It's not only, yes. So I think in the future we might have a better chance also maybe to finance some aspect of it through programs, you know? It's not completely, I mean, it's only the beginning, but I think the dialogue has started, and you know, they recognize that atmospheric composition is very important. So I hope that there will be more of a, more action there.
Yes, thanks for this remarks, Angela.
Yeah, this is Christian. This is Christian from ESA again. Well, also from side of the space agencies, at least from the European side. I mean, validation activities where we would typically fund, let's say, ozone sondes or other ground-based remote sensing instruments and so on. I mean, these happen within the frame of validation of a satellite mission. But a standalone program in ESA that funds any of these non-satellite measurements actually does not exist, and that's by mandate. You know, ESA doesn't have the mandate to do that. And that goes back to the member states and also to the national representatives of the member states, if they want these things to happen, no? Or who else in Europe is responsible for that, no?
Now, when I'm talking from Ozone Zones, working there now for 25 years to get the quality assessments on ozone zones, so just to get the data in the best possible quality, that's already difficult, but there was actually always what we're saying, and that's also what you're convincing always from the satellite people, is that the ground truth validation of satellite and the long-term stability of, especially the long-term stability of satellites is very important. And there the ozone zones give a very valuable contribution to that. So in that sense, there's maybe something where the ground-based and the satellite community should work more closer than it doing at the moment, because they are working in totally different agencies and organizations.
There are more and more bridges and linkage thanks to those coordinated programs like Copernicus, but indeed we can go further indeed. I'm afraid that we have to close this very interesting conversation if we wanted to go very quickly through the last topic, data stewardship, and I leave the word to Victoria.
Okay, so actually this is related to data access. Is convenient, and what should be improved, and other issues. Probably I should also say a few words. Actually, as you know that CCI pages are under reconstruction. And actually, in previous CCI project, it was only CCI data. They were on BIRA CP side. Now they are in the CCI data portal, and it is still under construction. And just individual project, it is all actually modification is more difficult. Because of it, this should be done centralized in specified data format. And so this still work to be done. And also some of the data, they are can be retrieved from Copernicus C3S services. And I would like also to note that even for some data sets, the data formats are different at the C3S and CCI. For example, for Copernicus services, there are special requirements how the data should be organized. While, for example, for I'm speaking about merged limb profiles, this is not optimal because of all the data sets are not huge and they can be easily just one file instead of monthly data split it into separately into anomalies and concentrations. So just this is not about how the data about the data access.
I would say that this is that depends on application, right? I mean,
yes, if you need just one additional month of data, then it is yes, it is much easier just download 1 month of data. If you are interested in trend analysis, then of course it's yes, it depends on application.
So Victoria, it's Mark. So I have a question. Is it then confusing for the user? Does he know when to go to CCI webpage and when to go to the C3DS? It could be complicating things that they go to the wrong portal to get the right data. So is there a clear guidance to which repository somebody has to go?
I hope that there will be clear guidance, and furthermore, I think that also the data should be also on CCI webpage. If it cannot contradict with this putting them into C3S, I don't know. Please comment.
Apparently, there are no further comments or questions. So maybe it's time to close the discussion. I don't know if Michel or Martin want to say something to close this day.
I think we are near the end of the day one of our workshop. Yeah, thank you. Big thank you in particular to all the presenters and the nice presentations of today, but also to nice statements and questions you have raised. So I think it was a nice first day. So I'm very much looking forward for tomorrow for the second part of our workshop. So we will meet again at 4 p.m. in the afternoon, Central European time. So I'm looking forward to see you all here and see all of you tomorrow. Bye-bye.
Bye-bye.
Bye.
Bye-bye.
Thank you.
Bye.
Bye-bye.
Bye.
Bye,
Take
everyone.
care.
Thank you.
See you tomorrow.
Bye.
You bye.